In this video, I will be discussing the derivative of exponential functions. So our set formula will be if y is equal to e raised to u, which is an exponential function, then its derivative is equal to e raised to u, and you have to derive u, multiply the derivative of u to e raised to u. That's the first form of exponential function, where e is a constant e and u is our function. Now for number 2, the second form is if y equal to a raised to u, where a is a constant base and u is a function, then the derivative of y is equal to y prime equal to copy a raised to u, write ln a, and multiply the derivative of u. So we have an example below. You have to derive the given exponential function. We have y is equal to e raised to 2x plus 3. So e is our base, which is constant e, and it is raised to a function 2x plus 3. So according to our formula, we will be using y prime equal to e raised to u times the derivative of u. So we have y equal to copy e raised to 2x plus 3 and derive what is 2x plus 3. y prime is equal to copy e raised to 2x plus 3, and the derivative of 2x plus 3 is 2. So we have to arrange the factors. It will become 2 times e raised to 2x plus 3. So this is our derivative. So we have our second example. We have y is equal to negative 3e raised to 5x squared minus 3. So from the derivative itself, we have y prime is equal to e raised to u du. We have to copy u, so we have y prime is equal to negative 3 and copy e raised to u 5x squared minus 3. And we have to derive our u is 5x squared minus 3. Now the derivative of 5x squared minus 3 is, so the derivative of this will be 10x. We have to multiply this 10x to our numerical coefficient, which is negative 3. So our answer will become y prime equal to negative 30x e raised to 5x squared minus 3. So our third example is y equal to 4e raised to the product of the two quantities 2x plus 1 and 4x minus 2. So as we take on y prime equal to e raised to u du, we have to copy 4e raised to 2x plus 1 and 4x minus 2 and derive our u. So our u is 2x plus 1 and 4x minus 2. As we take the derivative of these two quantities, take note that this is a product, so we have to use the derivative of a product in order to derive these two quantities. So let's derive. Copy first your 4e raised to 2x plus 1 and 4x minus 2. So the derivative of a product is y prime equal to u dv plus v du. So if this is our u and this is our v, meaning you have to copy u times 2x plus 1 times the derivative of v is 4 plus copy v, our v is 4x minus 2, and derive u. The derivative of u is 2. Then we have to simplify this whole bracket so that we could multiply it to our numerical coefficient for here. So simplifying this pink bracket, we have y prime. We have to copy this 4 raised to 2x plus 1 and 4x minus 2. So we have to distribute 4 inside as well as our 2. So it will become 8x plus 4 plus 8x minus 4. As we further simplify this pink bracket, we have to cancel out, or 4 minus 4 is 0. So we have 16x inside this bracket, or 8x plus 8x. 8x plus 8x. So we have to copy this y prime equal to 4e raised to 2x plus 1 and 4x minus 2, and to be multiplied by 16x. So as we continue this solution, we have to multiply 4 and 16x. So that would give us 64x e raised to 2x plus 1 times 4x minus 2. You can expand the exponent using FOIL method in order to make this two binomial become a general quadratic trinomial. However, we can still simplify the derivative of this given item by taking the product of these two binomials before we can derive. So in that case, you will be using the derivative of sum and difference because you will be having 3 terms later. So this is now the derivative of our function. Now let's take a look at the derivative of the second form of this exponential function. We have the given function that is equal to a raised to a function u. So its derivative is equal to the given function to be multiplied by ln a, which is also the given base, and to be multiplied to the derivative of u. Now let's have an example. The first example is y equal to 2 raised to 3x plus 5. So 3x plus 5 is a linear function, and that is the exponent of the base 2. Now in order to derive that, so we have y will become y prime. We have to copy the given function. That's 2 raised to 3x plus 5. And then you have to take ln a, or ln of the given base. So we have ln 2. At the same time, we have to multiply the derivative of u. So the derivative of u is d of 3x plus 5. So let me simplify below. It will become y prime raised to 2, equal to 2 raised to 3x plus 5 ln of base ln 2. And the derivative of 3x plus 5 is 3. Now let's arrange these factors so that there will be no conflict in terms of reading them. So we have y prime is equal to 3 times 2 raised to 3x plus 5 ln 2. However, as we apply the properties of logarithm, we can use 3 as the exponent of 2 because it is enclosed in a function ln. So meaning this can be written as 2 raised to 3x plus 5 ln of 2 raised to 3. Your 3 becomes the exponent of 2. So that's how are you going to write based on its property. But we can still simplify 2 raised to 3, that is equal to 8. That's 2 times 2, 4 times 2 is 8. So our final derivative will be y prime equal to 2 raised to 3x plus 5 ln 8. Example number 2. Of the second form, we have y is equal to 3 raised to 4x squared minus 3. So remember that the derivative of this will be y prime equal to a raised to u ln a du. So we have to copy our u is 3 raised to 4x squared minus 3x. Then ln of the given base, which is 3, times the derivative of our exponent, or 4x squared minus 3x. As we take the derivative of the given exponent, it will become, so this is our exponent, that's 4x squared minus 3x. It will become y prime equal to 3 raised to 4x squared minus 3x ln 3, and the derivative of 4x squared minus 3x is 8x minus 3. So simplifying this or rewriting this in a more readable form, it will become y prime equal to 8x minus 3 times 3 raised to 4x squared minus 3x, followed by ln 3. We can still distribute 3 raised to 4x squared minus 3x ln 3 inside the binomial. However, this form of answer is already acceptable. So this is the derivative of the given function. Let's have our third example. We have y is equal to 7 raised to e raised to 2x minus 7. So 7 is raised to e, and e is raised to 2x minus 7. So we will still be using y prime equal to a raised to u ln a du. Meaning we have y prime equal to copy a raised to u. That's 7 raised to e raised to 2x minus 7. Ln of 7 times the derivative of u. Our u is e raised to 2x minus 7. So we have the derivative of e raised to 2x minus 7. Take note that what is inside the bracket is in the form of e raised to u, and the derivative of e raised to u is e raised to u du. So we have to derive this exponential form inside the bracket in this formula. So let's derive. We have to copy y prime is equal to 7 raised to e raised to 2x minus 7 ln 7, and derive this blue bracket in the form of e raised to u. So we have to copy e raised to u, or that is e raised to 2x minus 7, and get the derivative of u. In this case, our u is this 2x minus 7, and the derivative of that is 2. So that's 2 minus 0 is 2. Then we have to simplify this and write it in the form where the reader could not be confused. We now have y prime equal to 2 times e raised to 2x minus 7 times 7 raised to e raised to 2x minus 7 ln 7. And by properties of logarithm, we can use 2 as the exponent of ln 7. So rewriting it, it will become y equal to e raised to 2x minus 7, 7 raised to e raised to 2x minus 7, and ln 7 raised to 2. So that's the numerical coefficient that becomes the exponent of 7. So simplifying, ln 7 raised to 2 will give us y prime equal to e raised to 2x minus 7 times 7 raised to e raised to 2x minus 7 ln 49. So that's the derivative of the given function.